C12 January 14, requested by someone. That's why this is the old paper. Find the first three terms in the ascending power of x. First three terms. So as I told you, this is 6c0, 6c1, 6c2. 2 is to the power 6, 2 is to the power 5, and 2 is to the power 4. Minus x over 2 is to the power 0, minus x over 2 is to the power 1, minus x over minus x over 2 is to the power 2. 4 and 2 is 6, 5 and 1 is 6, 6 and 0 is 6. 6 is 0 is 1, 2 is to the power 6 is 64. 6c1 is 6, 2 is to the power 5 is 32, and minus x over 2. 6c2 is 6, 5 divided by 2, 2 is to the power 4 is 16, and this is x square over 4. So this is 64, this is 2 cancel, 16, so that is negative 16 times. So this is minus 96x. 4 times 4 is 16, 2 times 2 is 4, 5 times 2 is 10, and 60. So that is, this is positive 60 x square. So the terms are 64 minus 96x plus 60x square. Quite easy. Question number 2 is fx is equal to (8x to the power minus 2) minus 4x to the power half plus 3x minus 1. We have to find the integral of this, that is f dash x. That is a differentiation. So that is 8 minus 2 x to the power minus 2 minus 1, that is minus 3, minus 4 half x to the power half minus 1, that is minus half, plus 3, differential of x is 1, minus 0. So this is equal to minus 16 over x cube. 4 by 2 divided by 2 is 2 over root x plus 3. So this is f dash x, that is a differentiation. Now integration. We have fx is equal to 8. Now we do the integration. 8 x to the power minus 2 minus 4 integration x to the power half plus 3 x minus 1 all dx. It's good if you write, if you don't write it's okay. So that is 8 x to the power minus 2 plus 1 over minus 2 plus 1. minus 4, x to the power half plus 1 over half plus 1, plus 3, x to the power 1 plus 1 over 1 plus 1, minus 1 x plus c. So this is negative 8 x to the power minus 1, and this will be 4 times 2 is 8 over 3, x to the power 3 over 2 plus 3 over 2x square minus x plus c. Question number 3. Find the remainder when fx is divided by x minus 2. So we put x is equal to plus 2 to get the remainder, that is 10, x is 2 is to the power 3 plus 27, 2 square minus 13 multiply 2 minus 12. So this is equal to 80 plus 27 times 4, that is 108, minus 26 minus 12. So that is equal to is it 150? This is a first part, second part. Now we put f is equal to 3 minus 3, x plus 3, f minus 3 is equal to 10 minus 3 cube plus 27 minus 3 square plus 13 minus 3 minus 12. So that is minus 270. This is a plus. This is 3 square is 9 multiply 27. That will be 81 times 243. That is 243 minus 39 minus 12. So this is, that is 0. So it means x plus 3 is a factor of fx. Now hence factorize it completely. So x plus 3, this is 10x cube plus 27x square minus 13x minus 12. So this is 10x square. 10x square multiply x, this is 10x cube plus 30x square. Negative, negative, this is cancelled. So this is minus 3x square and minus 13x. So we need minus 3x. Minus 3x multiply x is minus 3x square. Minus plus is minus 3 times 3 is 9x. This is plus, this is plus. This is cancelled. 13 minus 9 is negative 4x minus 12. So minus 4. This is minus 4x minus 12. So this is cancel. So one factor is this, another factor is 10x square minus 3x minus 4. Now to factorize it, 10 times 4 is 40. Are there any factors of 40? 10 times 4. This can be 2 times 5 times 2 times 2. 5 times 2 is 10 and 4. No. 5 times 4 is 20 times 2. 5 times 2, 10. Oh, this is not coming, so let's try another method. Two times 2 is 4 times 2 is 8 times 5 is 48 and 5 is yes. So this is 10x square minus 8x plus 5x minus 8 plus 5 is 3 minus 4. So that is equal to 5x common. No. How can 5 be common? 2 can be common. So 2x common. Yeah, this is 5x minus 4. Yes. Plus 1 common. 5x minus 4. So this is 2x plus 1 and 5x minus 4. So we can say that fx is equal to x plus 3, 2x plus 1 and 5x minus 4. So that is the solution. Answer this question without the use of calculator. You have to show this. So part A is, first part, that is 4 over 2 root 2 minus root 6. So we rationalize the denominator, that is 2 root 2 plus root 6 over 2 root 2 plus root 6. Divide and multiply by the, it's called the conjugate, means opposite sign. Now we are going to use the formula a minus b, a plus b is a square. So this is 2 root 2 square minus b square. In all surds where we rationalize the denominator, this is a must. It's always a square and the difference. Now 4 times 2 is 8 root 2 plus 4 root 6. So this is 8 root 2 plus 4 root 6. 2 square is 4 and root 2 square is 2. 4 times 2 is 8 minus 6. So it means this is 2. This 2 can be cancelled by this 4. This 2 cancelled by 2. So this is 4 root 2 plus 2 root 6. We have to prove it this. See, if this is root 2 multiply 2 is 4 root 2. This is 4 root 2 and 2 root 2 and this. So now I can write this one as 2 multiply 2 multiply root 2 plus 2 multiply root 2 multiply root 3. Root 2 root 3 is root 6 and 2. Now 2 root 2 is common. 2 root 2 and 2 root 2 is common. This I am taking common, so the remaining will be 2 root 2 common, so the remaining is 2 plus root 3. That is what we are supposed to prove here. Now we have to prove this one. That is second part. It says that root 27 plus root 21 multiply root 7 minus 6 over root 3. Root 27 is 9 times 3, so it can be written as 3 root 3 plus this can be written as root 3 multiply root 7, and this is root 7. And 6 root 3 can be simplified, root 3 and root 3. Root 3 is 3. 6 divided by 3 is 2, so this is minus 2 root 3. So this one is 3 root 3 plus root 7 is 7 root 3 minus 2 root 3. 7 and 3, 10 minus 2, so that is 8 root 3. That is what we are supposed to prove. u1 is 3 in this question, then u2 is equal to 2 minus 4 over n is 1, so this is u1. u1 is 3. So 3 times 2 is 6 minus 4, 2 over 3. u3 2 minus 4 over 2. This is u2. u2 is 2 over 3. So that is 2 minus 4 times 3 is 12 over 2 is 6 is minus 4. u4 is 2 minus 4 over minus 4. So that is 2 plus 1. So that is 3. So what we have here, 3, 2 over 3 minus 4 and 3. This series is not following any pattern, because if you divide consecutive terms you are not getting so it's not arithmetic geometric sequence. It's not a arithmetic sequence. It means it's following a pattern. So if you try to find the fifth term you will get 2 over 3, and sixth term minus 4, and seventh term 3. So it keeps on repeating it. So first term, second, third, fourth term, then fifth, first is 3, fourth is 3, first, second, third, fourth, fifth, sixth, seventh is 3. This is the first, second, third, 4, 5, 6, 7. So you see in this you will find it the 61 terms. So up to 60 is divisible by 3. So 60th term will be negative 4. 61 term will be 3. So this is just that's why this question is just 1 mark. That will be 3. Now you have to find the sum. So the sum of first 99 terms, they are repeating. So this is 3. Let me get the sum of first 3 terms. So 3 plus 2 over 3 minus 4. 3 times 3 is 9 plus 2 minus 12 over 4. 11. So minus 1 over 4 And how many are there? 33 terms are like this. So that is minus 33 over 4. This is not 4. This is 3. So this is negative 11. That is the answer. Given that a and b are positive constants, solve this. A, b is equal to 25. We can use any relation from there. We can use a is equal to 25 over b, or we can use b is equal to 25 over a. Now let's see this. Log a base 4 minus log b base 4 is equal to 3. Log number base 3 base 4 is equal to 3. So which number will be there? 4 to the power 3 is 64. So this is log base 4 64. This is the most important part here. So this can be written as log a over b base 4 is equal to log 64 base 4. Base is equal, anti-log will be what? A over b is equal to 64. B I can put 25 over a. So a over 25 over a is equal to 64. So it shows that a square is equal to 64 multiplied 25. So a will be root 64 is 8 and root 25 is 5. So a is 40. And b is, we can use from here, 25 over a, 40. 5 times 5 is 25 and 5 times 8 is 40. B is 5 over 8. I think it's a very easy question of 6 marks. Question number 7. This is sine square cos. So there is, change it into cos. So this will be 12 1 minus cos square x minus cos x minus 11 is 0. So this is 12 minus 12 cos square x minus cos x minus 11 is equal to 0. So this is minus 12 cos square x minus cos x, and 12 minus 11 is plus 1 is equal to 0. We change all the signs. So 12 cos square x plus cos x minus 1 is equal to 0. So that is what we are supposed to prove. Yeah, this is 1 mark. Hence find the solution of all this. This is part A. Now for the part B. (12 sin square x minus cos x minus 11) can be written as 12 cos square x plus cos x minus 1 is equal to 0. This is 12 multiply 1 is 12 and 4 times 3 is 12. So I can write it as, this is a quadratic equation now, 12 cos square x. This is a quadratic equation of the type, you can just write it as 12 a square plus a minus 1 is equal to 0. This and this equation are same. Instead of a, we are writing cos square x. So 12 cos square x plus 4 cos x minus 3 cos x. 4 cos x minus 3 cos x is just cos x minus 1 is equal to 0. I have taken 4 cos x as common. So this is 3 cos x plus 1 minus 1 common, 3 cos x plus 1. So I have 4 cos x minus 1 and I have 3 cos x plus 1 is equal to 0. It shows that cos x is equal to 1 over 4 and minus 1 over 3. These are the two values, the cos x. So we have to find the solution between this. So x is equal to cos inverse 1 over 4. So this is 75.52. Because one place of decimal it is less, so we are not going to write this 2. We just write 75.5. And this is 75. This one is cos ASTC. So another angle is this. So 360 minus. So minus 360. So this will be 284.47. So this is 284.47 is 5. So these are the two values. And when x is equal to cos inverse minus 1 over 3, so this is 109.5. So that is 109.5 and then negative is here, so this will be 2. This will be here 250.5 up to one place of decimal. That's all for today. Somebody requested again and again, so that's why I put the solution up to question number 7. Tomorrow morning you will find the remaining answer. Thank you, and don't forget to subscribe and like my channel. Thank you very much.